Andrés presents. I want to thank CSIC for replacing me for 2 months. Now she doesn't want to. She doesn't want to do anything anymore. I don't know what you did to her. You still help me. Thank you, CSIC. And yeah, Andrés, the floor is yours.
Okay, so I present myself. I'm Andrés. I work as a technician here in the media, but also this last month I did my master thesis with Fiona Thomas and Herbivory. So this master thesis is a meta-analysis on the effect of ocean acidification on the defense strategies against herbivores in seagrasses. So just to start, I want to introduce you the main character of this presentation. That is, they are the seagrasses. They are plants that in the past adapted to live in the ocean, and they play a really important role in the marine ecosystems. They have a lot of benefits. So, for example, for biodiversity, they are habitat-forming species, so they create an habitat for different kinds of fishes, crustaceans, invertebrates, among others. Also, they protect the coast by reducing the energy of the waves. So they protect, they reduce the erosion, and this is especially important in the case of sandy beaches. Also, they are climate change mitigator. They are photosynthetic organisms, so they absorb inorganic carbon. Also, they catch carbon particles in the water and they fix it in the sediment. So they are a sink of inorganic carbon. And also, they improve the water quality. They absorb also particles in suspension, and they make the water look more clear. So this is really important. For example, for tourism, a lot of people here in Mallorca, they come here just to look super clear water. And this is good thanks to Poseidon. So another important concept in this presentation is the herbivorism. Interaction between species is super important, and when you have a modification in one of these interactions, you can have a bigger impact in the whole ecosystem. This is especially important in the case of herbivorism. Is the first step to move energy and biomass from the primary producers to higher levels of the trophic chain. So that's why it is super important. And also they control the vegetative community of the whole ecosystem. And this process is especially important in the case of seagrasses because they are habitat-forming species, so they're even more special. So seagrasses, they are plants, they cannot run away from herbivores, so they have to face the problem. And so they have 2 strategies. Well, they have more strategies, but in this work, we are going to focus in these 2 strategies, the tolerance strategies. These strategies are the ones that try to compensate the loss of, for example, biomass by, for example, increasing the photosynthesis, the metabolism, using some morphological characteristics, or changing the distribution of carbohydrates and carbon content. Or they have resistant strategies that they use to look less attractive to herbivores. For example, increasing phenolic compounds that they use to create defensive structures, and also decrease the nutritional quality. So herbivores are going to try to find another richer species in terms of nutritional quality. So here we have a problem: climate change. CO2 is increasing in our atmosphere since Industrial Revolution. So it's a greenhouse effect gas, and our planet is getting warmer. This is here in the sea surface temperature, that temperature is increasing over the years. And also we have the other problem, ozone acidification. So as I said, CO2 is increasing in the atmosphere, and part of this CO2 is absorbed by the ocean. So this CO2, here we have this that is correlated with this one. This is the concentration of CO2 in the ocean. And also we have a decrease in the pH. That means that the water is getting more acid. So we have the problem of ocean acidification. And we know that this ocean acidification affects negatively to classifying organisms, but we want to know better how it affects to seagrasses. Here we see that CO2 interacts with the ocean, it's absorbed by the ocean, and when it goes inside the water, it interacts with the water and produces acid carbonic. So the water is getting more acid. But seagrasses, they can have positive effects of this process, they can have more inorganic carbon available to do photosynthesis. So they can be winners in a more acid ocean. Some possible effects of this acidification could be increase in the photosynthetic rate and its efficiency, reduce need of light, increase growth and biomass, and decrease below ground biomass. They have more affinity to this inorganic carbon rather than other compounds like bicarbonate or acid carbonic. So that's why they can be they can have a benefit of this. But if we study how it affects to the herbivorism, this response is not so clear. Here we have two papers where they perform herbivorism under ocean acidification conditions, and they saw different responses of the seagrasses. In the one in the left, they saw increase in the photosynthesis, in the leaf growth, and the short recruitment under acidification conditions. So they improved their tolerance strategies, and they didn't see changes in the resistance strategies. And in the other paper, they saw that the tolerance strategies, they didn't have a change, and also they saw an increase in the soluble phenols. So that means that they decreased the resistance strategies. So in that paper, they are better prepared to herbivorism, more defended, and in the other one, they are less defended. So the answer is not clear here. And so our objective is to conduct a meta-analysis to estimate a clear response of the effects of ocean acidification in seagrass herbivore interaction. So a meta-analysis, what is a meta-analysis? Sometimes, as you see, we have a lot of results, different results that could be confusing, some positive, some negative. So with a meta-analysis, we can integrate all the results of different independent papers and get a more statistically significant result, more clear results, considering all this data. So we have to follow all these steps that I'm going to explain a little bit. First, we have to select a topic and answer that we want to answer. Here is our question: how does acidification affect defensive strategies against herbivory in seagrasses? Then we have to find as many papers as possible dealing with this topic. So we'll look for different keywords in Web of Science, like ocean acidification, seagrasses, species of seagrasses, to try to find as many articles as possible. So we found 404 papers. Then we review the titles and the abstract of each paper to make sure if they were useful for us or not. So finally, from all these 400 papers, 404, only 30 papers were useful. And then we review each paper to see if they were following criteria. This criteria is that they must have a control and a treatment group. They must have values of pH or CO2. Also, we excluded all short-term treatments. They have to simulate the acidification conditions by introducing CO2 gas or in natural conditions, so like natural vents, natural CO2 vents where the CO2 gas is coming from the ground. And also they have to work with complete plants, not only fragments or little pieces of the plant. So finally, only 12 papers from these originally 404 papers were useful. So we extracted the data of these 12 papers from text, tables, or graphs using Webplot Digitalizer from 2019 to 2022. And we added all these papers to a previous database with already 38 papers from 1970 to 2019. So finally, our database includes 1,072 observations from 50 papers over the last 53 years. So once we have our database, we have to calculate the effect size. The effect size is a measurement that calculates the difference between two groups, a control group and a treatment group. And this way we can understand, we can magnify the effect of the treatment on a variable response. So the bigger is the difference between the two groups, the bigger is the effect of the treatment. Here, the acidification of the water. And to calculate that we applied the standardized mean difference. And here, then we have to apply a model. Here we applied a multi-level model The special thing of a multi-level model is that we can specify three levels of variance. The first one is the sampling error here, then the variance between the studies, and then the variance within the studies. So once we have our model, we validate the model, we analyze the heterogeneity. Here we have the distribution of the variance in the three levels, the sampling error level, the level 1, the level 2, and the level 3 between and within a study variation that we see that explains most of the variance. And also doing a contrastive test, we saw that there was a heterogeneity in our model, so part of the variability was not included in our model. And also we reviewed the publication bias. The publication bias is a thing that happens when magazines, they only want to publish articles with super significant and impressive results, and they don't publish papers with non-significant or non-impressive results. So they only show one part of the data, the reality, and they are not showing all the data that related to a specific topic. So here we have a problem now because this data is not reflecting the reality as it is. So we did a funnel plot. If these points, if they were well distributed in this triangle, we could say that there is no publication bias, but unfortunately, we have a publication bias because it's asymmetric. And also we did an error test and so we have publication bias. So moving on to the results. Just to understand better our model, we perform a statistical weight analysis just to see which factors has a higher representativity in our model. We saw that Posidonia, in case of the species analyzed, we see that Posidonia theanica, Thalassia, and Pitch, they have a bigger statistical weight, so they represent most of the model. Also, most of the studies were performed in the Mediterranean Sea, only in the Pacific tropical ocean. Also, we included ocean acidification treatments and temperature plus acidification treatments. And most of the treatments were only acidification, but also we have a few of temperature plus acidification. And then we included in situ and ex situ experiments in the natural conditions or in laboratory. So I'm going to explain you how to interpret this kind of graph, because in the next slides I'm going to show a lot of graphs like this. This is the effect size, the points are the effect size, and this code is the variable response that we studied. If here we have the line of no effect, if the effect size is positive, it indicates a positive effect of acidification on the defense strategy, in this case, tolerance strategies, and if it's negative, indicates a negative impact of the acidification. And also, we mark the significant ones with the asterisks. And also the summary of the group. Here we have all the variables related to photosynthetic activity. So here, what can we see is a significant increase for the maximum photosynthetic rate, the photosynthetic content efficiency, and a decrease of the compensatory irradiance. These three variables. So this is indicating us that the photosynthesis activity is increasing and becoming more efficient in acidification conditions. This is maybe because plants they have more affinity to this inorganic carbon, and they can use it to increase their photosynthesis. So they have more energy, to also develop more metabolism. Here also we saw a significant increase of two variables of the metabolism activity, the significant increase, the net primary productivity and the ratio of gross primary productivity and respiration. Also, some morphological characteristics increasing under acidification conditions. We saw a significant increase in the shot density, productivity, plant cover, and below ground biomass. So the plant is growing faster under acidification conditions, potentially fixing more carbon and being more tolerant to herbivorism. And also here we didn't see a significant response in the most of variables, but we saw here a significant response in that variable, that is the quantity of sucrose and starch in rhizomes of seagrasses. So maybe in under acidification conditions, they are saving more energetic compounds in rhizomes protected from herbivorism under below ground. And then moving on to the resistance strategies, here we have all the phenolic compounds. Here we cannot see a clear response, but only we see an increase in one variable in the phenolic in the lignin quantity. That maybe acidification has improved in the metabolism of this specific compound, but for the rest, the response is not clear. And in the nutritional quality, we saw that there is a decrease on the protein quantity, so maybe plants are becoming less nutritional in acidification conditions. And also we saw a decrease in the carbon 13 and the nitrogen 15 isotope. So that shows that the plant is using another source of inorganic carbon. So they are getting advantage of this excess of inorganic carbon and the acidification. Then we explore the moderators. We explore the overall effects of tolerance strategies and resistance strategies for considering different factors, different in this case species. And we see that different species, they react differently to acidification. Some of them, they have a positive effect. Here, for example, Posidonia oceanica has a significant positive effect. And the other one, Soltera muelleri, has a negative impact of acidification. And also for the resistance strategies is the same, and another species, they don't have a significant response. So that's really important because that means that this is not a rule. We have to consider different species that they can react differently to acidification. Also comparing in situ and ex situ experiments, we see more positive and significant response and in situ conditions, in regular conditions. That means that in laboratory conditions, usually you have more limitations. You cannot recreate the reality as it is, and probably plants are better adapted in natural conditions. Also here, considering the biome, the place where the experiments were performed, we saw only a significant result in the Mediterranean Sea. For the rest of the biomes, the response is not clear. Probably this is related because Posidonia oceanica has a positive effect of acidification, so is endemic here in the Mediterranean. So probably there's a relationship here. And also we saw more positive effect in the only treatments with acidification, but when we include temperature, this response is not that clear. So we suggest that temperature has a negative impact on seagrasses. And then here, this is the effect size during the time. So here we are considering the duration of the experiment, and we see that there is no effect. The duration of the effect that has no impact on the response of the plant. And then we have a few variables considering the herbivorism, and we see that also on the acidification conditions, the herbivorism is increasing. It's becoming more intense, the consume rates and the biomass consumed, both of them increased, but it's not significant, and then the overall effect is significant positively. So there appears to be increased consumer activity under acidification conditions. And also considering all these moderators, we see that the trend is basically positive in most of the considering most of the factors, and also the duration of the experiment seems to not have an impact. It's a little bit negative, but pretty constant. So here, comparing the overall effects of the whole model of resistance strategies, tolerance strategies, and herbivory, we see that all of them, they are having a positive, they are increasing in acidification conditions, and this effect is positive and significant in the tolerance strategies and the herbivorism. So maybe here we have seagrasses better adapted, so they improve their defense strategies, but also herbivory is becoming more intense, so maybe two processes are compensating each other. So conclusions, acidification has a positive effect on resistance and tolerance strategies in seagrasses, that is significant in the case of tolerance strategies. Herbivory increases under acidification conditions. we have to consider specific cases considering species and bio. Temperature is a stress factor. Significant positive effects under natural conditions, and the time or duration of the exposure does not have an effect on the responses of the seagrasses. And some limitation, we saw that our model has propagation bias, so we have to consider that. Also, we didn't consider all the moderators. There are more variability, more moderators that we should consider as well. Limited sample size. We had more data from some of the variables, but less data from the other variables. So the significance of the result of the less data variables could be affected because of this. And it's important to consider multiple treatments. Also, the temperature we saw that has a significant impact on the response of the seagrasses. So you have to consider that. So the next work could be a meta-analysis exploring the effects of the temperature on the strategies of seagrasses. So there's a lot of work to do. So we have to continue and explore. Basically, that's it. Thank you. Best thing you want.
I'm not sure I understood how you take into account the different biases in the papers that you in the meta-analysis, like for example, the fact that the Posidonia is dominant in the studies.
Yeah, our model is really influenced by Posidonia data, for example.
So we didn't like normalize the number of papers.
No, no. I mean, if you want to consider, for example, you can use moderators, and you can like this consider that the effect of acidification on Posidonia and all the variables related to Posidonia and another species. But of course, in our model, there is a big influence of Posidonia because there's a bunch quantity of paper working with Posidonia. Yeah, most of the data that includes our model is from Posidonia technica. Okay.
Okay, yeah, appreciate. Well, first I apologize because I arrived late, so I didn't see the first part. But how do you? I mean, I understand that you are trying to extract from several papers or you infer some effects, but I would say that each variations of CO2 increase variations is a dose-dependent effect. So, but you, as far as I understood, you are just considering it as a sole effect independently of the concentration. Or you take into consideration the concentration.
In this here we don't.
So that's important because most metabolism or the metabolism of autotrophic organisms is fundamentally regulated by Robisco enzyme. And Robisco enzyme is CO2 is concentration dependent. So you have a carbon fixation up to certain the concentration of CO2, and from there on, then you have photorespiration. So you have both effects that are related to acidification, depending on the concentration. So I think that's important if you want to infer something that is actually happening in the ocean. So depending how much is expected to decrease the pH, will have some effects and not other effects. And then, of course, in all those studies, there's also a bias, which is the plasticity of the organisms. Actually, most of those experiments are relatively short-term experiments. So it's difficult sometimes to infer what long-term changes will affect. But the concentration, I think, is vital.
Yes, I mean, in our data, we have pH and concentration data, and we could use like with time analysis of the concentration as a factor, and see how this response varies depending on the concentration.
Yes. So you just stratify by certain groups like pH lowering 0.22, 0.3, etc. So that's that you could actually find their different effects.
Yeah. See?
Coming back to the question, that I had with Posidonia, how much data do you have without Posidonia?
Without Posidonia.
Something observation, right?
Yes, here we don't see the observations. Sorry. I mean, the statistical weight is calculated using the number of studies and observations. Here we cannot say the exact number of observations on the studies, but here we can see how is the influence of these studies related with Posidonia. That is 26%. So
26% is without Posidonia?
no, just Posidonia experiment. Posidonia performed with papers performed with Posidonia plenica.
26%.
More or less, considering observation and studies.
Because one thing that you could do is remove the publications with Posidonia, so you will have 75% of your observations or papers or however you want to do it, and then we run the analysis. Some of the variables maybe they don't have enough replicates, but and you could see if these trends are mainly driven by Posidonia or not. You could reach conclusions with the other things because the paper is on Seagrasses and maybe Posidonia is having such a way that. But it seems like it's mainly positive, but I don't know. That could be a suggestion, and it's commonly done in the analysis. If you have something that weighs a lot, you remove it and then you rerun some of the analysis. The other thing for the variable that you don't have enough data, you could come with a threshold of the number of, and you can do it by number of replicates or by number of studies. So you could choose like 3 papers, and less than 3 papers, you can have run that analysis, so then you can have a more clear, well, it's not more clear, but the results that are significant will be actually quite valuable. If you have more than 3 publications for that variable, then you can get into stronger.
Thank you.
But I wonder if this is mainly driven by Posidonia or if it's all the same for the others.
Yeah, well, the good point is that once you have your database and your meta-analysis, you can explore all these kind of things. So, I mean, the considerations that you can have is like limitless, like so nice, but also I had a limitation of time, so I couldn't explore the
No, you have plenty, but grab some data.
Can you explain how you mentioned when you do the publication bias, because you can get the.
Well, actually, I'm not really an expert of this, but actually with our student, with our, I performed, I did this funnel plots. Basically, what I knew is that if this distribution were symmetric, there is not publication bias, but if this is asymmetric, there. And also the error test. I mean, I don't know how it works exactly, but if it's significant, you know, if it's significant to see that there's publication bias. I didn't know how it works, but I know that if it's significant, you have publication bias.
But like you calculate this, I mean, I guess you can calculate some kind of standard deviation on things. Like what is the quantity over which you calculate the variances? Like if
I don't know.
okay.
So did you find publication bias?
Yes, we found yes. The results of the statistical test, error test, and the funnel plot indicates publication bias.
Did you remove the one that the studies are?
We couldn't. I couldn't basically find which publication has publication bias and which are not. So I didn't remove any paper.
I think you can identify them.
I found some problems because we did a multi-level meta-analysis, and with multi-level is everything more complicated than random effects and fixed effects. So I found a lot of problems with that.
Did you take into account the robustness of the statistics of each paper? Because I get you have 50 years, I guess, maybe 50 years ago, you have 10 observations, while the
Yeah.
latest paper, you have 100. So
Exactly,
how did you
yeah.
take into account this change?
We didn't take it into account. But yes, of course, now, yeah. More and more papers.
More questions? No? Okay.